Hi, Jerry.
Hello, Brandon.
Hi, Neil.
Hello.
How are you guys today?
Mm, Fine.
You fine?
Mm,
Another fun week at home?
mm,
No, what's wrong? What's wrong, Neil?
Nothing. I just think it's not very good.
It's been a boring week at home. Okay, so this is called my entry ticket. This is our getting our brains thinking about science and what we've been learning. Hi, Andy.
Hi.
So we're just getting started, and this is our opening question for today. And I'm asking you, what do these two things do? What is their purpose? These two metal things, they're called prongs. What do they do? So what I'm going to do is I'm going to let you in the chat box. So on the black bar, look for this bubble. It's going to say everyone. So everyone in our group, in our classroom, can see what you write. So I want you to write down what you think these two things do. And I'm going to give you about, we'll say 3-4 minutes to write your answers. So you have enough time to type and think about what you want to say. All right, good. Got one from Neil. If I can get you to answer, Tina. Jerry says they make electricity cross them and that they are metal. Neil also said they can conduct electricity. Okay. It can, and Tina says it can let the electricity move. Okay. I think we have some good ideas of what those two metal prongs do. I'm not going to answer this question yet. We're going to come back to this question near the end of class, and we will go, and hopefully we'll have enough new information to let us know what those two metal prongs do. Okay? Jerry also did the second part of the homework, which was tell me some things he thought other students would have trouble with in our two previous lessons. And he noted protons, electrons, and discharge phenomenon as being difficult for other students. Jerry, can you go ahead and maybe tell us why you think those concepts were so difficult?
Because we don't think them in any time.
So you don't see it, right?
Yeah.
So sometimes it's hard to learn about things that you can't see in real life. Last week I gave you the rules of the classroom, and I think it's pretty easy. We all know we can raise our hand by pushing the button. And I tried to get you to ask some more questions during our lesson. So what I'm going to show you now is a video. I'm going to just show you a few minutes of it, but it's a video of some students having a discussion without the teacher. And I want you to pay attention to how they, as the students, take the role of the teacher, and they can have a good talk about what they're learning without the teacher there. So I want you to pay attention to this. More importantly, I want you to see how you four can talk together without me, which we're going to try and practice some more today, okay? So let's take a look at what these young gals can do on their own. Okay, so that's just an example of some students taking the conversation and being able to speak about what they're learning together. And I would like us to try and do more of that. and I think we can do it. I think we will get there today. So again, our goals today, which I think will be easier because both Andy and Nail will be teaching some of the class today. So Tina, I would like you, when you have questions, to write them in the text box, in the chat box, like we did with the first entry ticket today. And Jerry, you can say your questions to Andy and Nail. And Nail, when it is Andy's turn, you should also be asking him questions. So I want you to, I've put this slide on after everyone's presentations. So these are called open-ended questions. And these are questions that will make sure that Andy and Nail, when they're teaching us today, that we're getting as much information from them as possible. So tell me more about the electrical current. Can you tell me more about why electrical charge moves through wires? These are the kinds of questions we can make from these open-ended questions, and they make it easier for Andy and Nail to tell us what they've learned. Paper, okay.
Dry paper.
Dry paper. And Tina, you can always leave me a message, a voice message in WeChat, and I can share it with the class. All right, how about conductors? What are good conductors? Nail?
Metal and I am a conductor.
Yeah, we are conductors. And Tina said seawater. Yes, that was in our PPT last week, seawater. That's why.
Maybe
Yeah?
wet air.
And we're going to start with Andy. Andy's going to talk to us now about having what is current, and we'll let Nail do open and closed circuits. So Andy, are you ready?
So I don't need to talk about the open circuit and the closed circuit, right?
Yeah, we'll let Nail talk about open and closed circuit. You can just talk about current. Is that okay, Nail?
Okay.
Okay, and I've got the PPT open, so when you want me to go to the next slide, you say next, okay?
Next, I prepared some vocabularies about the current. Yeah, there are current, voltage, and resistance. And the symbol of the current is I. The symbol of the voltage is U. The symbol of resistance is R. Next, current is formed when the free charge in conductor moves in a regular direction under the action of an electric force. I found some formulas in the internet. It's when the resistance is constant. The formula of the current and voltage is R, resistance, equal U, voltage, divided I, current. And when the voltage is constant, the formula of the current and resistance is U, voltage, equal I, current times resistance, R. These are the pictures I found about the current in the internet. Thank you.
Good job. All right. So what I'd like now is I'd like Nail, Tina, and Jerry. I want you to ask Andy some questions about current, electrical current, and things that you might need help to understand, or however you feel. Here, I can go back to...
Is it a circle?
Ah, there we go. Great. Andy?
Actually not. The current is always moving, actually. So we don't know what shape is it.
Interesting. All right. And Tina asks you, how did you learn all of this?
By searching in the internet.
Thank you guys for all having a little something to say. We're on our way to meeting our goal of asking at least 3 questions in class. So that's great. Okay, so to review what Andy has said, charge that is flowing or moving is electrical current. So Andy was telling us about electrical current. So what do you do to make your fan or your TV work?
Use the switch and prongs.
All right, and so the prongs are doing something with the electricity from the wall, right? Great. All right, so let's learn some vocabulary for this part. So we're going to learn about circuits from Neil, and he's going to teach us a bit about open and closed circuits. But before we get there, let me teach you some vocabulary for this. So an electrical current needs a path to carry the charges. So this is kind of what you were asking, Jerry. You asked, is the current a circle? Why, yes, when the electricity is moving through the wires, it is needing to travel in a circle from one place back to where it came from. So a simple circuit has 3 basic parts. So another component, another thing that you can add to a circuit is a switch.
Some circuit is in the open circuit. That is, there is no circuit flowing on this road. The upside is closed circuit. The switch is in the closed state, like the open circuit. This picture, there is a lamp switch.
What's happening here?
The switch is open, but the line is not together, so the lamp can't.
So let's follow it from the source. So can you walk us through this, Neil? So we start here at the battery, negative side of the battery, then where does it go? Let's use our science word. This is the wire or connector. So from here, we go through the connector, and what do we call this part? What do we call the light bulb in the science word?
So the light comes.
Yeah, it's not going to turn on. So is this an open or a closed circuit?
Open circuit.
Great. So there's an opening in the wire. It's been cut. It is open. And how about Jerry or Andy or Tina? Can you tell me this second picture? Is this a open or closed circuit?
Open.
Open. And how do you know that?
Because the switch isn't turned on.
Yeah. So we can say the switch is not closed.
I can't hear clearly. Can you say it again?
So if the switch is on, it's a closed circuit, isn't it?
I think it's a closed circuit.
How do you know that?
Because the switch turns on and it can conduct the circuit and it can work.
And so I have two same battery. I put 2 battery in one circuit. Candle light.
If you have 2 batteries for one light bulb, will it be brighter than with one battery? Two batteries, is it going to be a brighter light bulb or the same brightness as one battery?
Brighter.
Okay, Andy says brighter. Neil, what do you think?
I think it's faster.
What is faster?
And the light will turn on faster.
It was your question, but how do you feel? What do you think will happen?
Because they are same. So maybe the light bulb can be more bright.
Okay.
If my question is if the switch is near the positive charge. So so if the negative charge first move to the light while the light on or off.
I think the switch must two charges were different. So the switch can't next to the positive charge.
I think if the switch is off, it won't be on.
I want to answer the question.
Yes, go ahead.
Because there is a limit to brightness of a light bulb, so it won't get any brighter.
I have a question for you. All right, we have a battery, one battery and one piece of wire. And I take the wire, one end of the wire, and touch it to the positive and the other end to the negative. So I have a circuit. Is this a good circuit? What do you think will happen? One wire, one battery, and I'm touching the wires to both ends of the battery. What will happen? Jerry?
It's dangerous
Why?
because the battery has resistance too, and the resistance is in the battery, so it could make a circuit too. So it would be more hot, and the battery would explode.
Awesome. That's some very good investigating skills you did there. And I really like how you thought that through. That was great. So we know from the battery we've got a positive end and a negative end. So what's going on with the wall? There only a negative end?
There's a positive and a negative end.
Ah. So
That this is the TV, and it has a prong, and it has negative charge and positive charge. And this is on the wall, and there's a like battery. The electricity comes from the wire, and the wall has negative charge and positive charge. So the two charges they touch, and it comes a current.
Circuit.
Circuit.
So when you plug something into the wall, you're completing the circuit. I'm going to send you this PPT with all the information. On the next few pages, there's this, it says analyzing data. So you're going to read these. You're going to read this chart. This is about an experiment with a balloon and cereal. The picture over here, that's breakfast cereal. And you're going to answer these 4 questions, okay? So you can read it and look at the questions. And then what I want you to do is make sure that you give me complete answers. Means full sentences, not just one word. No one-word answers, not okay. And then there are probably going to be some new words for you, so make sure that you write them down and use the computer to search for their meaning so that you understand the homework fully. But I think you'll be okay. So we did what's called an entry ticket today to start class. Now we're going to do an exit ticket.